Okay, let's finish up what we were saying in the last video. I ran out of time in that one. So we were talking about the size of nonpolar molecules. So if we have large nonpolar molecules, they will be held together with strong dispersion forces. If we have small nonpolar molecules, they'll be held together with weak dispersion forces. So let's take a look at some examples of what that means. So if we're talking about diatomic molecules, for example, iodine is pretty large when we're talking about all of the halogen atoms. So iodine exists as a solid at normal room temperature, where some of the other diatomic molecules exist as gases and liquids. So because those atoms are so much bigger, they're held together with stronger forces, therefore iodine is a solid. Okay? Something that is a long carbon chain, like C6H14. That would be 6 carbons. It's called hexane. 6 carbons all lined up in a big long chain, and that's H14, not 4. That would cause these to have strong dispersion forces because it's such a long chain of carbons. Hexane is a liquid at room temperature. Where over here, if we had really small atoms, like fluorine, for example, is diatomic, but fluorine atoms are really small. So fluorine is going to be a gas at room temperature because it has weak forces holding it together. If we talk about carbons, if we just have one carbon bonded to 4 hydrogens, CH4 is methane gas. And again, it's a gas at room temperature because it has weak dispersion forces holding it together. And then down here at the bottom of our flow chart, you can see that as we go from right to left, we are increasing the strength of attraction. So these are going to be the strongest attractions between molecules. These will be the weakest attractions between molecules. So to summarize, the first thing we have to do is know whether the molecule is polar or nonpolar. And how do we figure that out? Well, that's going to be, we figure that out based on the dot structure and the molecular geometry. So once we know the molecular geometry and we can decide if it's a polar or nonpolar molecule, then we can figure out what type of attraction there is between those molecules. Okay? So we're going to be practicing this the next couple of days. We'll see it applied in a couple of labs after we get back from Thanksgiving break. So make sure you bring your notes with you to class.